Okay, as we said, machine control unit is the most vital part of the NC systems. We said we have three parts. First is the part program instruction. Second is the machine control unit. The third is the machine tool or the machine itself or the equipment that we are going to control. So the machine control unit here consists of two main units, as we already mentioned before in the diagram here. So we said the machine control unit consists of two main units. The first is data processing unit. The second is control loop unit. So the data processing, the unit that will receive the part program from the program, the program instructions. Then the control loop units, the one that will send the action to the hydraulic system in order to perform the mechanical control on the tool or on the machine. So the definition here for the data processing unit or the functions or rules of data processing unit, it will read and decode the part program. We said it received the instructions, so it will read and receive the data, decode program. Then it will process the decoded information and provide data to the control loop unit. So the function or the task of the data processing unit is on the receive the program, interpret the program or understand what the program contains, then take action by sending the required action to the control loop units. So it consists from the following components. It has input device like RS232 port, then tape reader. Tape reader in order to read the tape punched. So the program is written on the tape punch. So the tape reader here will read the program written on the tape part. Then the punch tape reader here, the data reading circuit and parity checking circuits. So all these circuits to check the, the received data from the program and also to check the error and code to interpret the coding. Then decoder to distribute data to the access controller. So the decoder here, it will decode the written data or the written program in form of the hole on the tape punch, and it will transfer it into the coordinates axis of the controller, because we said most of the machining tools here are related to some coordinate system. So length is how much, width how much, depth how much, and so on. Go rotate clockwise, rotate counterclockwise. So the decoder here will translate this coding from the program, and it will inform the control unit or or the circuit which is responsible to give the action to the next unit, which is the control loop unit. So the control loop unit here, the function or the task. If I ask you what are the main functions of control loops unit, so you have to state these are the main function for the control loop unit. When we say the machine control units, that means we include both the data processing unit and the control loops unit. So the control loops unit here receive the data from the DPU or the data processing unit, convert it into the control signal. As we said, the output or the actuators or the machines which is connected to the controller will or need some electrical signal to take action. As we said, for example, for the valve case, if you have a valve, you want to control the valve, we said we open the valve, how many percent depends on what is the signal or what is the voltage, electrical signal. So here the loop control unit will convert the received signal from the data processing unit into a electrical signal to be sent to the machine under control. So send the signal as electrical signals with some coordinates. Send the control signal to the hydraulic system, as we say here. This is your hydraulic system. So the control or the control loop units will receive the data and convert to the suitable signal to the hydraulic system. So hydraulic system is responsible to take the mechanical action on the tool. go right, go left, rotate, and so on. Depends on what is the written program inside the code. Then interpolator to supply machine motion commands between data points. So since it is connected to the hydraulic system, so it's more involved in the mechanical action of the machine control unit. So it will be responsible to move or to rotate the machines based on the input or the required or the desired value that received from the program. Position control loop hardware for each axis of motion. So you have, for example, if the machine consists or has 2 axes only, 3 axes, 5 axes, 6 axes, depends, 4 axes and so on. So it depends on how many axes. Usually we have 3 or normal axes or the like X, Y, Z, but also you have some rotational axis. So X, it has another axis around X, clockwise, for example. Like for rotational, also Y, it has another rotational axis and so on. So most of machines has more than 2 axes. So usually 4 axis, 3 axis, like this one. So this unit also responsible for positioning control for the loop hardware for each axis of motion of the machine. The last unit here, we said the first one is the program or part program instruction. The second is the machine control unit, which consists of the data processing unit and also loop control unit. And the last one is the processing equipment. And processing equipment here represents the machine under control. Drilling machine, milling machine, turning machine, whatever is the machine. So this we call it the processing equipment. And processing equipment or machine tools here perform the actual productive work. When we say actual productive work, that means it is responsible to perform the action on the device or on the product. So you need to cut the product, so the machine will be responsible to do this cut. You need to drill the product, so the machine need to perform this drill. You need to make multiple holes in the product, so the machine will perform such task. So processing equipment represent the machine tools, and actually its operation is directed by the program of instruction through the MCU. So you have the program as input from the operator, go to the MCU. MCU will give this or read the program, understand or interpret and convert it into mechanical action through the hydraulic system. And this mechanical action through the hydraulic system will be sent to the machine equipment to perform the required task on the product. So in machining here, the processing equipment consists of work table. Usually if you see here, if we say this is the machine, this is the machine system here, you have the tool here, you have the work table. So these are usually also as you can see here, if you have such machine, this will be the control unit on the top here. So if this is, for example, control unit, or this one is the control unit, or that one is the control unit, also you have here, this is the machine equipment itself. And you have the table inside, like this one, the table of working, where you place your part that you want to product and so on. So you have some movement part of the machine here, go right, go left, and so on. Also the same here, this we call it the work table or workspace of the machines. So we have work table here. We have one or more spindle, motor, and controllers. So the motor here and spindles use the motor, for example, usually used to rotate the machine. If you have, for example, drill, so the drill, it has a machine inside or a motor inside to rotate the drill clockwise or counterclockwise and so on. So you have spindles, you have also cutting tools, you have work fixtures, and also all these tools depend. Actually, the work table is common in all machines, Also, the motors is common in all machines, for example, but other devices like cutting device, fixture device, and so on, there some machine depends on what is the machine that you have. Is it for drilling, for milling, and so on. There is other auxiliary equipment needed for the machine operation, depends on the type of operation itself. So this is what we call it the processing unit. So this is the third part of NC system or numerical control system. Now, why we need NC or why we use NC or why the Air Force in US asked the MIT to produce or to develop an NC machines. The main aim for NC here is to increase production, because if we depend on human only, so the human actually, especially for such hard work like for cutting, for drilling, and so on, it's very hard. I mean, it's not easy to perform by human manually. So for that, if you have such machine, it will increase the productivity of your system. It will reduce the labor cost. Why it reduce the labor cost? Because instead of using, for example, 100 workers, you may need for only for 10 workers like this one. So it will reduce the labor cost. Even if you have one worker, I mean less number of workers, also you can give them less salary because their work is not hard to do. Their work, for example, to stand beside the machine only, to give the command to the machine, to enter the program to the machine. It's not more on the hands hard work. Okay, to make production more economical, since you decrease this cost, for sure the product will be less cost and it's more economical to do job that would be impossible or important impractical without NC. For example, there are some of the tasks which is people themselves they cannot do. For example, in drilling, for to cut a steel, for example, if you I mean, or a steel with a very big diameter, so it's not easy to perform cut for such by using hands or by using human only human force only. So for that you need to have such NC machine which can perform such impossible task to be carried out by humans. To increase the accuracy of duplicate parts. For example, you want to design one product, but this product you are going to produce it for thousands of times. So it will be very easy if you have a machine. So you give just you develop the program for the machine and you enter the coordinates for one product. Later on, it will be like copy. It's like for photostat machine. You see, photostat machine, instead of writing the page and rewrite it again for 10 times, you just put it in the machine. It will copy it for you for in maybe in few seconds. So it will increase the accuracy also, and especially for the duplicated parts. So this is why we need the NC machine, and also this is a part of the advantage of NC machines there. Better control of the tool motions, because actually human are not that accurate. Some people also now, I mean, it's not easy to enter the dimensions, or I mean, or to adjust the dimensions and coordinates manually. So, but when you enter it like as a program, as a code, you just enter number with letter, so you got the specific or the particular coordinate that you are looking for cutting, for drilling, and so on. It's become more specific rather than using the ruler and the meters or the measurements tool to measure what is the length, what is the width, what is the height, and so on. So it's better to use the machine. Then improved part quality and repeatability. So as we said before, the quality, if you have multiple parts or you have a product, you want to repeat to produce this part for hundreds or thousands of times. So if you produce the first part is okay and you test it is good in good conditions, so you just repeat it again. So you will decrease the fault or I mean the failure in the production lines. Then reduce tooling cost, tool wear, and job setup time, reduce time to manufacturing part, reduce scrap, better production planning, and placement of machining operation for the hands of engineering. So all these are advantage of NC over the conventional machines. Okay, so for example, I mean, if you want to improve the productivity, if you want to improve the quality, if you want to produce or to increase the number of products, reduce the scrap, all these things, you have to use NC. Don't use the machines that was existing before 1952, which is more slower. I mean, it's more depends on human, more depends on hands worker and so on, without any programming, without any accuracy or reliability and so on. Okay, so this is the advantage of NC, but NC also has the limitations. I mean, it's not when we compare the advantage or disadvantage of NC, we compare it with the previous generation of machines. I mean, like the machine without any type of numerical control. But also NC is not the best. NC is also has limitations. For that, people or the manufacturer, they develop, or the inventor, they develop another type of numerical control. They call it computer numerical control. And also CNC is not the best. For that, they come to improve it by using CAD, by using CAM and so on. So the limitation of some of the limitation of NC here, comparing with, not with CNC, no, comparing with the previous machines. When we say limitations of NC, comparing with the conventional machines or the manual operating machines. So it's higher investment cost, it's more expensive here, higher maintenance effort, because since you have more equipment, I mean, you have control unit, you have hydraulic system, you have program reader and so on. So it's the maintenance is become higher because it's need more professionals or more technicians, skilled people. So part programming issues. So need when we want to develop the program, I mean the part programming here, we need to have skilled programmers. So skilled programmers, that means also it will require more money to develop the program. Not anyone from any labor can or any worker can go to work with these machines. Time investment for each new part. So I mean, if you want to develop one part, for example, the investment, I mean, to the return, to return the cost that you spend to build this or to buy this NC machine, you need longer time when you work with some manual machines. Higher utilization is required for this machine. So I mean, don't just buy NC machines just and leave it there, because if you leave it there, you cannot return its cost. So you need to utilize NC for produce more and more